Hello guys, in this video I'm going to show you how to solve all missing numbers problem. So find all missing numbers we're given is unsorted array containing numbers taken from the range 1 to n. The array can have duplicates, which means some numbers could be missing. Find all those missing numbers. So this one is pretty similar with the previous one in this category that we've already saw, which is the missing number. The difference is in the previous one there's only one missing number, right? Let's take a look at that. Okay, there's only one missing number, right? And also another difference is numbers taken from range 1 to n. But for this one, the source numbers are from 1 to n, right? And also we have to find all the missing numbers, all the numbers that are missing, right? So wait a minute. The idea is same here, as we have to this kind of problem. We want to bring every number to its correct positions, right? Using cyclic sort, right? So let's try to see how gonna do it manually. Let's say we iterate to every number, right? The first one. Let's say wait a minute. We first I'm gonna write out the indices of every number 5, 6, 7, and 2 life. For it'll be easier if you're gonna add the source array, right? Because our input is taken from the range from 1 to n, right? So our source will be 1, 2, 3, 4, 5, 6, 7, 8, right? So as you can see, number 8 at index 7, number 7 at index 6, and so on. So we can conclude that number x at index x minus 1, right? So our goal while iterating to every numbers in the input is to bring the current number into its correct position, right? So number 2, what is its correct position? It should be at index 1, right? Number 2 should be at index 1. So we make a swap. So index 1 is now holding 3, right? So we're gonna swap 2 and 3. 2 here and 3 here. Okay. 2 has gone to its correct positions, right? but now 3 is at index 0, which is not right. We again uh, 3 must be at index 2, right? So index 2 now is 1, right? So we want to swap 3 here and 1 here, right? So as you can see, 3 is at its correct positions. Now let's check. 1 is also now is at correct position now, right? So we can move on to the next number. Okay, 2 is at index 1, which is correct, right? 3 is index 2, which is correct. The next one is 8. 8 should be at index 7, right? Okay, at index 7 is 1 now, so which is not correct. So we swap 8 here and 1 here. Okay, here the interesting thing, after moving 8, bringing 8 to its correct positions, right? We're now checking 1, which is not at its correct positions, right? It is at index 3. However, its correct position is index 0 is holding another one now. So probably we don't want to process this guy. We don't want to make a swapping in this case. So for this scenario, we just move ahead, right? Next number 2, same here. There's already another 2 at index 1, so we just move ahead. Same here, 3. There's a 3 at index 2. Move ahead. Okay. 5. 5 is at should be at index. Let's say 5 should be at index 4, right? And at index 4 now is 2, which is also not correct, so we make a swapping here. 5 come here and 2 come here. Okay, again 2 should be at index 1, but there's another 2 here or there, so move ahead again. 8 is at index 7, which is correct, so we move ahead and finish iterating. So now, as you can see, we do as much as possible to bring number to its correct positions. And now let's try to run through it again, right? To see where the duplicate is sitting. 1, which is correct. 2, which is correct. 3 is at its positions, but now here is the duplicate, right? Here's a duplicate, but we need to find the missing numbers, right? So the missing number is the number that should be at these positions, right? We're not going to return current value, which is 1, but we have to return the number that should be sitting here, which is 4. That is index plus 1, right? Same here. So missing, we have the first missing number is 4. Okay, the next one 5 is correct. 3 is not correct. There should be a 6 here instead. So 6 is the next missing number. 2 is not correct, so 7 should be here. Okay. The next number is 8. 8 is at correct position, so we're done with second loop, right? So now let's try to code it out with the logic that I've explained, right? So we need to for the first loop I'm gonna use a while loop, right? So wanna start from index 0, and as long as I is less than, let's say input is nums, is within the range, right? Wanna go get into the loop, right? So the current number is nums at index I, and its correct index is current number -1, which is here, right? Number x should be at index x -1, right? So we only want to make a swap if the current number is not at its correct positions, right? So it means if probably if the correct index, so current number should be at correct index, right? So if the current index is not equal to correct index, it means the current number is not at its correct positions, right? And the other case that we have discussed earlier, which is the numbers that is currently sitting at the correct index is how to say the current number that is sitting at the correct index is the right one, right? So it means we have duplicates here, so we don't want to make a swap if the number at correct index is equal to, here the values, right? So a number is at correct position when the value is equal to index +1, right? Correct +1, right? Okay, if this is the case, we want to make a swap. Whoop. Wait a minute. if I minus n, it should be not equal, so we only want to swap only if the current number is not correct positions, right? The numbers at the correct index. The numbers that is at correct index. Is not at its right positions, right? So it means we only swap if both, right? Both positions are at wrong positions, right? So we want to swap I with correct index, right? So either case is not true. Wanna run into else. If we don't swap, then we want to move ahead, which is increase I by 1. And okay, let's do the swap in separate functions. Let's say I'm gonna pass in the arrays as well. Num in x and y. We want to do a little bit of JavaScript trick here. Num I and nums y. Here we reverse it into nums y and nums x. Right. Okay, perfect. Here the first iterations. We must do another iterations to find the missing numbers. Let's say missing numbers, right? Okay. After all, we return missing number. So if let's say we start from I equals 0, right? I less than nums of length I plus plus. Okay. Let's say so if the current number, which is nums at index I, is not at its correct positions, is different from nums I is different from its index plus 1, right? Then it's not at correct positions, and the number that should be here is I plus 1, so we push the missing number is I plus 1. Okay, I think that's it. Let's try run the test, right? Five. Okay, wait a minute, just 5 and 3. Okay, oops, it's not correct. What's wrong here? What's wrong here? What's wrong here? We have two failed tests. So let's debug it. Not sure what's wrong here. Let's try to navigate first. As long as I saw the numbers. Okay. Columns I is going index is the value -1. Okay. So if I is different from the current index and not the correct index, right? Or the number is correct in the correct index is also not at its correct positions. If I check the value is different from the index +1. Okay. If this is okay, we want to swap these together. Otherwise, we move forward one step. What's wrong here? Okay, another loop. Start my 0. Okay. Nums is whoa. If the wait a minute, it should be here. Okay, that's it. Sorry for silly mistakes. So that's it for our problem. So thanks for watching. See you in the next video.